Frank, you told me you're saying a little bit about yourself,
Okay.
and so I would just hand over to you, and thanks a lot, and we're looking forward for your talk.
Thank you. Well, I would be nervous if it was the very first time I've been on this stage, but it's actually the second time. The first time I actually had the whole crowd singing, and I won't do that this time, but we had a hackathon here earlier this year. And unfortunately, my hackathon team ended up blowing up a lot of circuit boards. So I had the whole audience singing up to the tune of Smoke on the Water, singing Smoke on the Breadboard. So on this stage, so I'm pretty comfortable here. So I've been in Vorarlberg for about 8 months. And like Thomas said, I'm here because of the technology. When I first came to Vorarlberg about 1.5 years ago, I was like, well, there's a lot of cows and farms here. A lot of cheese, a lot of beer. But then I started digging into the covers a little bit and seeing what else is happening here in Vorarlberg. And it was really interesting to find so many cool technology companies, so many interesting people interested in just talking about technology. And when I went back to Seattle, I said, look, I worked for a consulting company called Slalom, and I was like, look, you people have to get into this area. It's like Silicon Valley over there. Everybody's really excited and energetic. And they were like, what, Austria? So I quit my job and moved here. So I work at Inet Logistics here in Dornbirn as a data architect, and I consider myself a blockchain evangelist. I also just put my IBM champion thing on there because I just won that award again this year. I was an IBM champion in 2014 for streaming data technology, and this year for blockchain, so I'm pretty excited about that. Doesn't mean I work for IBM though, so don't feel like I'm biased. And there's my email in there. So, blockchain. Everyone is new to blockchain. If someone tells you they're an expert in blockchain, they're probably lying. Or they're trying to sell you an ICO or something. But what's interesting to me is that trying to put a pin in the map of blockchain, where it is right now, what is happening right now with blockchain, is notoriously hard. And it's not just hard because of it's new, it's because there's so much stuff happening in it right now. If I have a tutorial for something, for example, to do with blockchain, I'm trying to learn how to do something new in it. If I'm not using the absolute most latest and greatest compilers, the latest and greatest libraries, stuff blows up all the time. You have to be very patient with it right now. So a lot of it is very new. But also, I love this quote from Sarah Baker Mills at IBM that the visual language is still being codified. That means the diagrams that I use to show you, to illustrate concepts, the way we talk about blockchain, the metaphors that we use, the analogies that I use to describe things are also still being developed. And that's really exciting to me because I really like talking, as you'll see, and I like talking in metaphors sometimes. I always give this little caveat that I was not a science or a computer person in school. I was an English literature major, so I speak a lot about metaphors and things. But it's a very new language, this whole world of blockchain. And when I say everything is new to blockchain, my coworker Thomas said, yeah, but you said that a couple months ago too. So who here has no idea what blockchain is? So everyone in this room has heard something about blockchain. Oh, there's someone in the back there who has no idea what it is. Great. So when I first started describing to people, I found that I would either get very technical or just kind of woo-woo about it, as I would say, not really able to describe it to them in a way that was tangible. But then I came up with this great idea. In Europe, or I'll say in Austria or Germany, when you were growing up, you had a savings account maybe, and you had this thing called, I'll pronounce it correctly, a Sparbuch, that you would go to the bank and you would take money in to them and give it to them, and they would accept it, and they would write down in your little Sparbuch how much you had, and you would get it back, and you'd go home and think, oh, I got €5, yay. So I like to describe some of the underpinnings of blockchain as a magic Sparbuch. That is, it is a ledger of information, It's cryptographically signed. That means it's secure. It's irrevocable. Once something was in your Sparbook from the bank, could you get rid of it? Could you erase it? Well, you could, but why would you, right? You could change the numbers in, but when you go into the bank, they're going to know you did it anyways. But what's magic about this Sparbook with regards to blockchain? What's magic about the Sparbook of blockchain is that everybody has the same one. Everybody has one of these magic Sparbooks that have the same transactions in them. And I'm not going to get too much into just cryptocurrencies tonight, that's sort of the exchange of money with it, because there's an underlying technology of this Bitcoins and other cryptocurrencies called blockchain, which to me is much more interesting as a technology person and as a data person. And I'm going to introduce you to some concepts. I'm going to show you some quotes, some funny jokes on the screen, and then we're going to get into some ideas about what you can do with blockchain today and what is being done with it today. And hopefully we can have some conversations around what would be interesting just as totally crazy ideas around it. And then what to do with those crazy ideas too. Do you guys get Dilbert here in Austria? I kind of put like, oh yeah, it'd be something you immediately get. There is a lot of hype about blockchain right now. In fact, Gartner Group has what they call a hype cycle. Some of you might have seen that. We're very high on the hype cycle with blockchain. There is an iced tea company in America that changed part of their company name to blockchain. That's all they did. They didn't change their recipe. They didn't change their product. They just put blockchain into their product name, and their stock went up by like 150% in one day. So when I heard that, I immediately went out and registered the domain name Blaukchain, so .at. So another great quote. So Bitcoin is what most people know about blockchain. Now, I didn't see the end results here. Who here has Bitcoins or cryptocurrencies of some sort, right? Who here does not? Of the people that do not have them, do you want them? Just raise your hand if you want them, if it's interesting to you. It's kind of an interesting idea. Come see me afterwards. I'll give you some Bitcoins. Don't worry. Actually, I've given a talk similar to this one at the Mutterschiff, the Digitale Initiativen group over here in Dornbirn, and I always ask, so who here has Bitcoins? And a few people raise their hands, like, who here got those Bitcoins from me? So there's a few people here who have, but not many. But Bitcoin was how this all started. Bitcoin was what was inspiring people to write this technology. But the next generation of it is what's really exciting to me. And I will tell you, I'm old enough to remember before there was a World Wide Web, before there was even an internet. And I remember the first time I saw a browser. It was something called Mosaic. Anybody here remember Mosaic? Okay, you're all over 40, right? And it was beautiful to me because I knew a little bit about hypertext at the time because I was an English major and a lot of the libraries used hypertext to describe documents. But to me, it was sort of this large, tag-based, kind of hard to read sort of thing. But what Eric Berners-Lee did is he took this and wrapped it in a visual interface and said, I can now link to objects, I can link to pictures, I can put this out there and you can see all this stuff visually. And I was like, whoa, holy crap, that's going to change the world. That's the way I feel about blockchain technology today. It's an incredibly simple design pattern. It's an incredibly simple technology to describe non-technically, but what's really powerful about it is all the different things that this technology is going to enable. God, I put a lot of quotes on the screen. I even took some of them out. So when blockchain was first started, people were using it to store value. That is, value of cryptocurrencies, things that had value. And all the technology around it, the miners, the wallets, the brokers, and all that kind of stuff, and all these tools came out, and they came out in support of this idea of exchanging value. But now, this underlying technology is beginning to build use cases that go way beyond just exchanging money. and just reinventing money. So when you exchange something with someone, when you want to do an exchange of something, and we can use money as an example, but it doesn't have to be the only one. Typically, you have something called an intermediary or a broker that validates the transaction for you. We're going to exchange something. I have something you want to pay me for it. We have to have some way of proving that I gave it to you and you remitted me for it. So in today's economic world, we have this idea of brokers. Examples of brokers: credit cards. Right? A credit card is a broker of a transaction. It proves, hey, I'm going to pay this to you, and then you pay it to me, and they take a fee. That fee that they take is really important, right? Because that funds their ability to be a broker. With blockchain, and also the identity management. We'll come back to identity management in some of my later use cases. When you go to a broker, and let's talk about a bigger broker, like a platform broker, like Amazon.com. You want to buy something from Amazon.com. They require a lot of information from you, don't they? And they track a lot of information about you. I was reading this morning about how you can find out what Google knows about you. And there's all these links you can go to that'll show you all these incredible things that Google knows about you. And it's frightening. Never Google yourself. But that's the price you pay for participation in these platform technologies. With blockchain, it's not necessary to do that. It's not necessary to give away all your information to affect a transaction. And I don't want to get too down into the weeds of how the transactions work, because then we get into math, and then I'd have to resort to asking Thomas math questions, and it would get really embarrassing for me. But I want to stick to this idea of use cases. So in blockchain, which is a peer-to-peer network, that is, it's not centralized on one broker, your identity is your own. You don't have to share with people information that you don't want to. Your identity is your key, in essence. And as long as your private key that identifies you is private, your identity is completely your own. So if I want to exchange something with you, I don't have to tell you anything more than my key. Unlike doing a transaction with Amazon, where you got to give them all this information about you, they're tracking information about you via your browser, and you're giving up a lot of your privacy. Also, with blockchain and with the currencies or any of the assets that you have stored on the blockchain, they are also your own. They're not stored in a bank. They're not stored with a credit card company. They're not stored under your mattress like some people do. They're your own. And they're your own to spend and to accumulate on your own. Now, the opposite of this peer-to-peer is a platform. And a platform is something like Amazon, a Facebook, and a platform business has this weird side. I had a graphic for this, and I kind of debated putting it in or not. But if you think about eBay, Amazon, and Facebook, they allow you to create transactions to do things. In order to do that, you give up your information, and then you pay them to do something, and that invokes trust with them. Okay, I kind of assume Amazon's going to send me the stuff, and that trust allows them to get bigger transaction fees, and this cycle continues, it perpetuates itself until you have these huge, huge platforms, and Jeff Bezos is now worth, someone tell me, $150 billion or some crazy number like that. So the other thing about a platform is that everybody is operating in the same sandbox. You don't set up your own Amazon. Amazon is Amazon. They control it all. It's all very centralized. And but the important thing about platforms is that you have to be able to do stuff on it. And one of the criticisms of cryptocurrencies and blockchain in general is, what can I do on it? I can't buy anything. Can I buy a house in Bitcoins? You sure can. I don't know if every place is going to let you, but you're going to see more of that. Can I actually buy dinner with Bitcoins? There are some places where you probably, anybody know any restaurants that take Bitcoin, take crypto payments? Somewhere, maybe in Vienna or Vaduz or someplace, there's someplace that does, I don't know. There's actually Bitcoin ATMs now. There's one here in Dornbirn, and there's one in, I know there's one in Vaduz. The only thing is, the minute you start using an ATM to get money in and out of Bitcoins, exchanging them into cash, what happens? Fees. And what are those fees like? Huge fees, yeah. I worked for a company in Seattle called Coinstar. Anybody ever heard of Coinstar? Coinstar lets you take bags of money, coins, and dump them into a machine, and it goes, and it hands you money, a little slip at the end of it. It says you deposited, all your quarters you've been saving for 20 years, and you get $80. Except we take 10%. Or as time went on, they took 11%. Then they took 12%. And that was their business model, basically, was to get a piece of that transaction. So those are platforms. So how is a blockchain different from that? What are the basics of a blockchain? Well, you can think of a blockchain, it has three components. It has data, that is the content associated with it. It has a network that it runs on, and there's not lots, but there's many different networks that you can run your blockchains on. And it has logic. It has rules by which these transactions happen. And again, this gets a little bit technical, but I wanted to put this in here because I really like this language of object-oriented design. And object-oriented design has been around for a while. If you're a developer, you undoubtedly write in object-oriented languages in 2018. I can't imagine anybody writing one that's not. And the things that we do inside of the blockchain world kind of map pretty well to object-oriented design. And we're going to talk about those when we get into the design patterns in a little bit here. The storage for blockchain is by definition, because everybody has a copy of the transactions, it's decentralized. There's no one database of the blockchain. I actually have the entire Ethereum blockchain, which is a network, on my laptop under that desk. And I'm sure there's people in this room. Who else has a copy of a complete chain on their laptop in this room right now? Maybe not right in this room, but in the next room over, right? If we were to compare ours to each other, they would be identical. It's the magic Sparbook, and we both have it. It also has a concept in it of consensus. And consensus means, in the blockchain world, that we all agree on the order and the veracity, the provenance of the transactions in it. And the math behind this, how this all happens, we can save that for another talk because it's a completely different talk that I probably have someone else give for me. But the idea is anything that goes into this magic Sparbook, all the participants have agreed it's supposed to be there. That's the important thing to remember. And if something tries to go into it that everyone doesn't agree on, what happens? It doesn't go into it. It doesn't go into the magic Sparbook. So it's also immutable. There's no way to delete something from the magic Sparbook of the blockchain and have your transaction record still be legitimate and still be usable. So I've used the word decentralization a couple times, and I want to talk a little bit about what I mean by that, because that is sort of an underlying concept of blockchain. So in the beginning, way back in the dark ages, we had standalone computers and applications. Anybody here have a Radio Shack TRS-80 or a Atari C64? Yeah. These were standalone computers. There was no networking. God, that's craziness. How are you going to plug two computers together, right? And then acoustic couplers. Anybody here ever use acoustic couplers to dial into networks? Now a few more hands raised, And then maybe RS-232 networks. Anybody have those? Yeah, we're getting a few more hands. But then networks came along and computers could talk to each other. So the relationship between two computers is what we call clients and servers. Clients make requests and servers respond to requests. But we had to wait a little while. In the early days, there were competing protocols. There were competing standards for networks. Anybody here become a certified netware administrator at any point in their life? You had to learn a protocol from a vendor practically at that point in technology. So we had to wait a little bit for TCP/IP to take over the world, essentially. And then we had to wait for some cryptography. We had to wait for good cryptography standards to come along. And I have discussions with my coworkers all the time about, is it good enough? I don't know. The math people say, yes, but I could break it if I had a quantum computer and blah, blah, blah. Yeah, it's good enough. But we also had to increase local storage. When I tell you I have a copy of the entire Ethereum chain on my laptop, what does that tell you about my laptop? I have little bit of storage on there. I have at least a terabyte or so to play around in on there. But computers themselves had to have more local storage in order to enable this to happen, this sort of decentralization idea. And computing power. We had to have enough horsepower on these machines, not like the machine that your father-in-law or someone uses who has 2 gigabytes of RAM and one processor, and he wonders why he can't do videos on it, which literally just happened last weekend. And then you had to have millions of users, everybody sort of participating in this ecosystem. And then what are we going to do? In decentralization, we take away the servers. We say the standalone computers, the standalone mobile phones function as clients and servers in this world. And we can actually do this because there's enough power down on these devices to do it. Now, there's still a place in the world for servers, obviously, mail servers and file servers and all kinds of good stuff. But what's happening is this idea of a central computer that has to respond to all your requests isn't really not necessary to operate in the new world of decentralized applications. So, I debated putting this slide in or not. I'm going to come back to this actually, because this is about design patterns, and this is about the kinds of things that we do as we're developing applications. But just really quickly, as we're talking about all the possible use cases that you could conceive of for blockchain, these are the patterns that I use to say, does it fit for me? Does it actually have the things that I need to do? And there's really 3 categories of these solutions as they relate to this isn't just a blockchain concept. This is sort of a software development concept in general. But I need to be able to create things. I need to be able to create objects, code, whatever. These things need to have structure. They need to be able to be organized. Say something may be a tree structure. Well, I need some way of facilitating, creating, and managing a tree structure. And they need to do stuff. They need to have behavior. I may need to, for example, look across a list of objects and do something to all of them. And that's a design pattern. And so these are the kinds of things that I look at when I'm evaluating applications, when I'm evaluating ideas, including blockchain ones. It's a little bit nerdy, but... so visually speaking, what did I just walk through? I talked about centralized applications. What does it say? Station and link on it? I don't even know where I got this. So this is the world of client server, right? You have all these clients on the outside. Oh, I have a pointer on here somewhere, don't I? Right. Oh, look at that. If you were cats, you could run around on the floor. So in the middle, you have your server. On the outside, you have your clients, everybody talking into it. And the difference here is you have decentralized, where these clients and servers are no longer in one location. They're all sort of distributed around and sharing them. And then you have fully distributed, where there's actually no centralization at all. And this is the world that we're moving into with computers, with transactions. I come from the database world, and my entire career has really been involved with dealing with database servers. And all of a sudden, this is starting to shift a little bit in the last couple of years, where does that data really need to live in a database server? Or can I do something decentralized with it? Can I move that data off somewhere else? Is it really useful to have it in a centralized server? When I interviewed for my position at Inet, I remember telling my future boss, I don't really want to do databases anymore. He's like, yeah, but you're interviewing for a data architect job. You know, you have to do databases. I'm like, oh, God. But databases just, I've been doing them for so long, they just aren't that interesting to me anymore. What's really interesting to me is how can we distribute data around? And blockchain is really a great enabling technology for that. So, what does it mean to have applications being decentralized, or what you'll hear referred to as dApps? Terrible name. But there it is. They are programs or contracts, which we'll come back to in a second, that allow this collaboration on these peer-to-peer networks. So there's no middleman in the transaction. We're just, all the stuff I described earlier, we're actually functioning transactions, affecting transactions with each other. It's immutable, our magic spar book, right? You can't make changes to it. It's traceable. I can trace back how something got in there, how it happened. And very importantly for doing transactions on sort of the real world is that the same money can't be spent twice. That's a pretty important concept, right? If I'm selling you something digital and you're paying me something digital, it's pretty important not to be able to take that digital money and go buy something else with it also at the same time. And this magic sparbook concept enables that. Your agreements can be multi-party, that is, we can have 3 or 4 people affecting together. And most importantly, what I described earlier is you own your own data. So if I'm doing a transaction with someone, I don't have to go through what is their Amazon ID. I don't have to go through, you know, what's your mother's maiden name and your social security number and all that stuff. We can relate to each other for the purposes of this transaction with just keys to identify ourselves. And so you own your own data, you own your own identity. It's a very different way of looking at data in the world. So what are some themes of decentralization? Well, as you know, governments and businesses thrive on centralization. That is central bureaucracy, centralization, and control. And in this, say, world of, well, the example that I was talking about earlier with someone was notary publics, where you're, what's the German word for notary? Quick. Yeah, that. Where you pay someone to be a notary for you, to say this document is official, right? In the world of blockchain, you wouldn't need to pay the government to do that. You could actually just do it with each other. Now, what does the government do with that money they take from you for that? This is not a political group, but... And this is my side note here, is that let's say we remove the ability of governments to tax transactions, to tax any sort of sale. What happens? There's no government, exactly. Now, the libertarians and the anarchists, they love all this, but the idea of social contracts, that is, who pays for roads, things like that, is a really important one as we start to develop these decentralization themes, is how do we fund our societies together? I don't have an answer to that. So remember, there are no experts, but it's something that I'm interested in talking about, and people are doing interesting research work on how we can do sort of like ethical blockchain work in that world. But remember, decentralization doesn't need a middleman. And I don't know if some of you remember a couple years ago, there was a Bitcoin-based network that was transacting what? Illegally? Drugs. Funny you would know that, you know? His coworker. You have to get them somewhere. God, you know, what would Keith Richards do? And they could do that because there was no middleman in the transactions. Of course, they had a fatal flaw. They had to mail the drugs to people. And you put a pretty bureaucratic middleman in the process there called the Postal Service, and that's how they all got caught. But decentralization, by definition, does not need a middleman. So I look for, okay, who would be ripe for decentralization? And the organizations that would be ripe for decentralizations are one where there are high tolls, high transaction costs, including the pharmaceutical industry, particularly generics. Investment banking takes huge cuts of money. Tobacco, drug, biotech, and of course banks. These are all organizations. And if you go out and Google blockchain and find fintech, who's doing stuff, these names are going to pop up because people know these are key industries for this technology. So, what do we build to enable? What slide am I on here? I'm about halfway through. Whew. Okay. So what do we build to affect these transactions? Well, we build something called a smart contract. And this is a lot of blah, blah, blah. But a smart contract is a piece of code that you write, and you publish it to the blockchain, and people can interact with it. So for example, I want to create something that says, Frank Blau is identity A564. It really isn't. Don't worry. Don't write it down. And I want to say, anytime I want to transact business, I want to be known as A564. I would create or use, if someone had already written it, a smart contract that managed that relationship. And it would function exactly that way every single time. And all the things that I told you about, how that guy over there has a copy of it, he has a copy of it, he has a copy of it, all those things still happen with these smart contracts. The same thing that happens with your Bitcoins. As a matter of fact, you can think of Bitcoins or any cryptocurrency as just another contract that runs on the blockchain. The thing that we're transacting happens to be what, though? Currency. We're basically transacting value. But that's not the only thing we can transact. And when we get to the use cases, you're going to see some pretty interesting ideas. So, what's a simpler way to describe smart contracts? It isn't something that I cut and paste out of Wikipedia. So, smart contracts are programs that run exactly as their creators designed them. And they're small. You can ask Thomas. My favorite quote is, how many lines of code? 5 lines of code. I can do anything in 5 lines of code. Smart contracts are typically not big, long applications. They're pretty small, granular sort of things. And there's a reason for that. When you run these programs on the blockchain, there's like a little, I don't like to use the word tax, but there's a little fee for running these programs. They call it gas. It sort of funds the whole process. And this gas goes up in value or up in cost as your transactions and your data storage gets more complicated. So by definition, people make these contracts really pretty small and simple. But they're self-executing. Once I write it, it runs. If I write a transaction, a smart contract to store my name and the address that my utilities come to or something like that, it executes itself. I don't have to go and say, okay, run the program now. No, by nature of calling it and actually submitting it to the blockchain, it runs itself. You can do things with contracts like talking to other contracts. For example, I may have a contract that does nothing more than manage my identity. Frank Blau, A564. Now, A564 wants to pay a bill. Not Frank Blau, A564. I have 2 separate contracts. There's one contract that manages my identity, and another contract that manages some transactions that I want to effect with it. I can transfer assets between accounts. I can say, here's some Bitcoins, and when I sign up for your music service or something like that, pay 0.5 or 0.005 Bitcoins to you, and boom, they go to you automatically. So you can transfer assets around. So what do I get from smart contracts? They provide, this is a list that you'll see on 100 different web pages actually about the benefits and sort of the things that you get from smart contracts. But one of the first things you get is autonomy. You are the owner. There are no lawyers. Usually I get a cheer when I say that. There are no lawyers. Yay! No, my lawyer, is he watching? Oh, shit. Okay. You get trust. Because we all share a common understanding of what happened, there's built-in trust. You get backup. There's many, many copies of the ledger. If my laptop goes south on me tomorrow, I can download the whole chain again tomorrow, assuming I still have all my keys and they aren't on a hard drive that I put in a dump somewhere and lost millions of dollars in Bitcoins, which actually happened to someone. They're safe. They are the expression that we use is they are technology enforced, not people enforced. So when something is accepted as a transaction, it's enforced by technology, not by people. They're immutable. You can't change them. Speed. Okay. This is an issue that is probably on the list of questions people are asking already. Is how fast can I do transactions on this blockchain world? Not very fast, like maybe 20 transactions per minute. Anybody here know what we're up to on Bitcoin? 20, 30 transactions per minute, something like that. It's pretty slow. When you talk about the world that I come from, of streaming data where you're dealing with millions of records per second, that isn't the world that blockchain plays in today. And that's going to happen, though. There are new technologies coming along. There are new ways of providing blockchain services that allow you to do much faster transactions. Savings, you're not paying the middleman. So there's a cost saving there. And there's accuracy. As I said before, they execute exactly as the code is written. Because the code is simple, it's easy to understand what it's doing too. And because of this, I can show you what my contract is doing, and we can agree this is the contract that we're going to be executing with each other, and it's going to execute that way exactly every time. So, now we're getting to the fun stuff. But I want to preface it with, there are lots of use cases. people have lots of ideas, and they bring a lot of them to me too. Like, I have this great idea for a blockchain application. And, well, not all use cases are good business cases. And there is one of my things, as I say, just because you can build something doesn't mean you should. Although I'm often asked why I'm doing something at work, and I say, because I can. And I'm going to skip that slide. I want to go to this one. So this is also, you see this version of this slide a lot of places is, do I need a blockchain? And it's a simple flow chart to say, you know, if this, then this, is this something I really want to do with a blockchain? But I want to give you an example. Someone talked to me a couple weeks ago about designing a service by which agricultural companies could exchange products. I have fertilizer, you have a farm, I have apples, you want applesauce, whatever. Being able to exchange stuff with each other. And they were like, this would be a great blockchain application. And I was like, what makes it a good blockchain application? Well, because we can do an ICO. I'm like, initial coin offering is how you raise money in the blockchain world. I was like, okay. So let's talk about it. Do you really have trusted relationships? Are your relationships with your customers the kind of thing where you need to have these immutable transactions with each other? How much data do you want to store? What kind of speed do you want to do these transactions at? And after you walk through any version of these sort of blockchain flowcharts, should I do a blockchain flowchart, you'll realize that not everything is a good blockchain application. That being said, I don't like to discourage people from thinking about blockchain applications too. So we're going to talk about some pretty strange use cases sometimes. So one of the things you have to decide when you're talking about a blockchain use case is, what kind of network is it going to run on? Am I going to run on the Bitcoin network? Am I going to run on Ethereum? Am I going to run on some other network? And the decision to choose a network, to me, and this last slide here, there were sort of three choices down at the bottom. Unpermissioned, cryptocurrencies, public ledger, anybody can use it. Permission public ledger, I say who can be on my network or not. And permission private, that is, it's a bank or someone like that. It's a closed system. Those are kind of your three choices for pushing this code out into the world. On those networks, you have to decide, is what I'm doing something that has to interact with the public or not? So for example, if I set up a private permission network, that is, I'm saying who gets to belong to it or not, how do I enforce it? One of the things that makes the larger cryptocurrency, the public blockchain network so powerful is there are millions of people on it. Millions of people have this copy of the Magic Sparbook, right? And so you can't cheat it. If there's only 4 of us in the network, and 3 of them decide they want to cheat the 4th person, can they? They absolutely can. So when you're doing private networks, when you're doing these private permission networks, one of the things you think about is, okay, what is our relationship to each other? How are we going to establish consensus, and how are we going to enforce that consensus? And sometimes, and again, you go back to what I said earlier about the lawyers, is you need lawyers. You need a legal basis for these private networks. That is, if someone violates the private network, you can't just say your transaction is invalid because they actually own more of the network than you. So you need another sort of structure around what you're going to, how we're going to enforce that. So how do we decide what kind of network we want to run on? So we want to think about, what kind of consensus do I need? Do I need public consensus, or is this just a couple of people that need to agree with each other? Who can access it? Who has control over it, and who governs it? That's also really important. And if there's an asset in the system, say it's a currency or tokens or whatever you're doing, who controls it? Who actually defines it? Who says what it's worth? All those kinds of things are things you want to think about. Who can issue it? In a public network, who can issue things of value? In a private network, who can issue these things of value? And of course, security. I'm certain that on the list of questions coming to me, what's it called, Slido? Via Slido, there's going to be some about security. And it's a really important topic when it comes to cryptocurrencies, because everybody has an example. What was it, last week somebody stole $150 million in Bitcoins from some wallet system, it wasn't a fault of the network. It was a fault of the application who was running it. It was a fault of the broker. But you do need to think about security. Okay, now some interesting business cases. How are we doing time? My watch isn't keeping crap. Okay. So there's some really big names getting involved in blockchain right now. And one of them that I came across when I was putting together this deck was Barclays Bank. And what they've done is they've taken the idea of a letter of credit. And a letter of credit is basically a document that says, you're going to pay me for something that I give you. And right now, that is a very manual process typically. Things are faxed, things are mailed, things are scanned, sent to each other. It's a slow paper-based process. And you can actually execute transactions in hours for huge sums of money. Like just the one example that I saw was $100,000 in agricultural products. This letter of credit attached to it saying, I'm going to give you these agricultural products. You're going to pay me for them. From my perspective, maybe it's a little more than 5 lines of code. That's a pretty simple contract to write. We could actually execute that transaction in 4 hours instead of 2 weeks. So there's a huge savings there. Another interesting idea that I came across here, I've actually been talking with some people about, is the idea, anybody here know what Know Your Customer is? It's a European, we don't have it in America because we don't even know any of our customers. It basically says that if you're transacting business with someone, you have to know who they are. If you're accepting money from someone, you have to know who they are. It's a very bureaucratic process. A lot of documents have to be sent around. There's a lot of things have to be sent around that says, okay, I've tracked the chain back to this person, but they only own 10% of the company, and the government says that's not good enough. You have to own more. You have to know who owns more than 25% of the company. So here's all your paperwork back again, submit it again. All of this could be done with smart contracts. All of this would be really easy to put together into smart contracts, and I think there's a good case for that. Insurance claims. One of the things that happens with insurance fraud is people will submit the same claim twice, maybe 2 different insurance companies, whatever, or for the same incident. Because the blockchain-based technologies are immutable and things like that, you could actually eliminate some of those claims. Now, how we're going to do that with insurance companies that are notorious brokers, they're also notoriously bureaucratic and control freaks, I don't know yet. A lot of this stuff, I'm going to go back to my first slide, that we're still inventing this technology, but there's some interesting ideas for use cases there. This is the field that I'm in right now, supply chain management and logistics, tracking the transportation of goods. One of the things that makes for an interesting blockchain use case to me is a particular type of relationship between the parties. And I refer to that as a semi-trusted relationship. What that means is you do business with each other, but you're really not on the same accounting system. You really don't completely trust each other. You need something that sort of verifies this trust with each other. And that's a perfect blockchain use case. And so we're investigating ways to enable blockchain in this world, in this world of logistics. And Maersk Shipping Company, you see their name in all the boats all over the place. They're in a big project with IBM right now for things like container management, for things like tracking the movement of goods in ports. All of these things fit perfectly to this blockchain model of decentralized, immutable transactions. Healthcare is also another interesting one because healthcare, almost every transaction you do in healthcare involves your personal information. What if you didn't have to share all that personal information when you did a transaction? The example that I give is vaccinations, right? If you have children and you want them to go to school, there's a list of vaccinations that they have to have. And what happens is if you move around a lot, maybe between the children were between the ages of like 0 and 5, you may have had to go to like 10 different doctors to get all these shots for your kids to go to school. And maybe there's a piece of paper that shows shot number 3 and another piece of paper that shows shot number 4. All of that information could be stored on the blockchain really easily. And the other thing that's cool about it is that what does the school have to know at the end of the day in order to admit your kid? All they need to know is yes or no, this child has its vaccinations. They don't need to know the doctor's names. They don't need to know the dates. They don't need to see the nurse's signature. All these things that are your private information could be contained within the contract, and then the school would just have the authority to ask, hey, does this kid have all of its shots or not? Yes or no. Boom. Really cool use case. Other interesting use cases I mentioned earlier, real estate, validating financial information. That is, I have so much in the bank, and I'm going to let you know that for a week. And when that week goes by, you no longer have access to how much I have in the bank. That's very different from the way transactions in this world are done today. You sort of give away your information, and now this mortgage company or whoever has more information about you than your doctor sometimes. So the other interesting case, a world that I worked in for a while, was title insurance. And title insurance is the process by which you verify a particular piece of property has the right boundaries, there's no hazardous waste on it, this is what's built on it, this is the history of that property. This is also something that would be a really nice use case for blockchain, because you don't need to modify it per se, but what you need to do is you need to verify the provenance of it between semi-trusted partners. Another area where there's a lot of interesting work being done is in energy management, and there's sort of two different sides to it that I see involved in blockchain today. One is in just sort of the financial side of energy management, that is dealing with consumers, dealing with access points in the home and things like that. And the other is actually in the transmission transactions. If you think about how energy moves around on a grid, you may be two different companies that don't completely trust each other, but they need to share electricity, something that's happening in real time. And there's some interesting blockchain use cases for being able to create those transactions. I mentioned identity management earlier. If you think about the one I just talked about with utilities, let's say I have a house and I have power, sewage, and water. 3 different utility companies, possibly, that I'm dealing with. In today's world, I'm the same person to all 3 of those utilities. Maybe maybe I have different credit cards for them, I don't know, but really it's information coming out of the same account. And that could get complicated if the building, say, is an apartment building. It could get complicated if I decide to build an apartment downstairs or something like that. And one of the ideas that's been percolating around with some people I'm talking to is maybe we can provide identity management for utilities, where for my electric bill, I'm A564, and for my water bill, I'm A565, and for the electric bill, I'm A566. And that way, as I move around, as it changes, I can actually modify my relationship with the people that are providing those services to me as needed. So that identity management. Some other interesting use cases, voting. If you go to any of the development sites for blockchain tools and things like that, the one that you'll see very often is a ballot. And because it's like 20 lines of code, and I always tell people you can run a complete democracy, not in America, on these smart contracts. But voting is a perfect use case for blockchain technology. We don't trust each other, certainly not. But we need provenance. We need some way of saying I can only vote once. We need some way of saying that my vote was counted. And there's interesting work being done around blockchain in voting systems. Another really cool one that a friend of mine in Seattle is working on is source control for open source technology. So open source is software that's sort of like shared development, and it's out there in the world. You can download a copy of it, make some changes to it, submit the ideas. Maybe the group agrees it's a good idea, then it gets published. And his idea is to sort of compensate developers using cryptocurrencies and things like that for the use of good source control tools like Git and things like that. It's a pretty interesting idea. Storing data. There's a lot of interesting sort of, I'll say, ICOs, work being done about doing file storage using blockchain. Because of the speed of blockchain, because there's other competing technologies like Amazon's S3 and stuff like that, I'm not convinced that data storage, we're quite ready for it yet, just because of the speed and the volumes. Patents and intellectual property. A patent is a perfect example of something that would work well on the blockchain, because let's say I invent something and I want to make sure no one else steals that idea, or at least if someone does, I can prove I thought of it first, right? What do I do now? It's a really complicated process. Anybody here ever tried to get a patent? It's a messy process. It takes hundreds of thousands of dollars and lawyers, and it's really, really messy. What if I could just say, hey, here's the patent, here's my blueprints, put them on the blockchain. If someone else 5 years from now comes along and says they invented it, I can actually prove beyond a shadow of a doubt, completely authenticated, that on this date, I submitted it to the blockchain. It's my idea. Give me my $1 million. Another amusing one, marriage and divorce. You all laugh. But I would say that marriage is that a smart contract? I refuse to answer that question on the grounds that it might incriminate me. But it certainly is something that people have done, created these contracts that say that this party of the first part, party of the second part, here's the terms of it, and we agree that on this date we're married. Now, none of this stuff is blessed by the city or the church for that matter for this kind of stuff, but that to me is like, that's just gravy. Stuff like that's going to happen eventually. But of course, marriage on the blockchain, very simple to agree to get married, but just like in real life, divorce would probably be very difficult too. But maybe you could specify some terms about that in there. I don't know. Interesting use cases. This is one I was going to put in there. So this is some higher level stuff that when you are creating these contracts that you want to think about. These are some of the conversations that I have with people when they bring me their crazy blockchain ideas. I'm like, okay, who's going to interact with this contract? Who are your customers? Same thing that you would do from a business perspective with someone saying, I need a database, right? You say, okay, who's going to interact with this database? What's their behavior and what are their incentives to participate in this system? Right? Why would I go to you to do this when I could go to a platform to do it? We described platforms earlier as sort of the competing idea space behind this. The context dependence, there's a lot of best practices around development in this world of blockchain, but don't be locked into them because the technologies are changing too fast. If you lock yourself into saying, I'm only going to do things a certain way, something's going to come along next week that's going to blow you out of the water. It's really kind of the Wild West right now in this world of, and so don't be as dogmatic as you would say, for example, with a mature technology like say Java or something like that, where there's really solid best practices for Java-based applications. This world is shifting all the time. But, and this is one of my Vorarlberg stories. When I first was interviewing with companies here, I was interviewing with a utility company here, who will go unnamed, and they said, so tell us, what your philosophy is for development. I'm like, well, I'm kind of a fan of Jeff Bezos. I think Amazon's a pretty cool company. And Jeff Bezos has a sign on his desk that says, fail faster. And they all went, we don't fail in Austria. This was kind of a foreign idea. And with regards to blockchain technology, that's also very true. Because these smart contracts, once you create them and put them out there, they're immutable. The cost of failure in this world can be very high. And this last sentence, money can be bricked and lost. That is, I can create a contract that can have money sent to it that can never be retrieved. I could write that contract in 5 lines of code. So could you. So you have to be careful when you're developing these contracts that you're actually writing them well, that you are testing them thoroughly, and that you are vetting not just your usage of them, but the 3 role analyses up here. What's the incentive for people to take advantage of this? How could someone possibly take advantage of this smart contract? Development methodologies. I just threw up a couple things on it. This is also something that changes every week. I just put up a couple of interesting things on here, the places that I go to. And the last one on the list here is our local organization, the Digitale Initiativen, and we meet at Gelbfabrik here in Dornbirn on Thursday evenings. And we talk about technology. I teach people how to write smart contracts all the time. Taught that young lady right there how to write a smart contract in 30 minutes, something like that. Okay, she's a good developer, but if you want to learn how to write smart contracts, if you have an idea for something, come talk to me. Come to our meeting or just send me an email. I have my cards up at the top here. If you really think this is something that you want to learn how to be a developer in, and honestly, anyone who's in the development space right now, I highly recommend it because it is going to be the technology. I'm happy to show you how to do it. It's really easy. It's fun. If you know anything about development, it's super, super easy to play with. And there you have it. Okay, I think we have some. Do we have some questions? Yeah. Thank you.
Thanks first.
And Thomas is going to translate them for me.
Yeah, some are in English already, so we can directly start off. First, thanks for your question. We nearly got 40 questions, so...
40 questions. Okay, so let me just... I'm going to throw one thing out here, is that if you have specific technology questions like EOS or Ethereum, I saw another one up there about blockchain. Let's take those offline because we're going to lose a lot of the business people in the room if we get into sort of technological differences. So we can take some of those offline. I want to kind of keep the Q&A to business stuff if we can. So
yeah, that's absolutely fine.
Yeah.
And if you want to vote on some of these questions, so there's still movement in there. There's just the ones that are voted up most. You're invited to do so. So the first question is, I would say we can tackle that because it's also about business kind of. It's how much energy is needed kind of to do to run the blockchain technology, and how are you going to cope with these like energy needed in the blockchain world?
So there's a two-part answer to that. One is that the existing world of consensus, that is what we decide on, how we agree on these magic Sparbooks, they use a technology called proof of work. And I can get into how it works, but it's probably, I'd bore half the people in the room. But it uses a lot of computing power to agree on the order and the veracity of the transactions. It uses so much power to run these calculations that you can actually end up paying more for electricity than you're making money from your transactions. So this question of energy has become very, very salient in this world of blockchain. And so there's a new kind of technology coming out for consensus called proof of stake, which is still being sort of developed and pushed around a little bit, and kind of ideas being poked around on it, that actually reduces that by orders of magnitude and make it much more energy efficient. So I guess my answer to the business people in the room is this is being solved. It isn't completely solved yet, but it's being worked on, and people recognize this as a real stumbling block that needs to be addressed. And proof of work is just not going to scale out to the kinds of applications that I've talked about today.
Perfect. So the next question is about security. You also said you're kind of seen that before, that it will be a topic, security. So how can it be secure if almost every hardware runs on these proprietary software components?
Wow, that's a good question. I don't have a good answer for that because the things that we've seen gone wrong with blockchain have almost always been a fault of brokers in the middle with having problems with their technology, not so much with the blockchain itself having fundamental issues with it. So yes, you could, there could conceivably be something come along that I couldn't, like who foresaw Spectre and Meltdown 6 months ago? No one had even heard of them. So I don't really have one answer for how we can solve that particular technical security problem. But I think the idea of consensus, the sort of the business perspective that I gave you, if we all agree on the list of transactions and all that kind of stuff, makes it a lot more secure. But just like with protecting, I don't know, server rooms, for example. I saw a great Amazon talk once. A guy says, okay, you all think your on-premise server rooms are secure, more secure than Amazon's? Who has keys to your server room? Have you done background checks and psychological profiles of everybody that has the keys to your server room? We at Amazon do. Do you have the fingerprints of everybody who has access to your server room? We at Amazon do. You know, I kind of feel the same way about blockchain technology, is that there's a fundamental secure framework for it, but it's only going to be as strong as the people that have the keys into it also. So if you work for a broker company, for example, you work for, say, a Coinbase or someone like that, and you have access to the database that stores the information, you have just as much ability to corrupt the system as anybody else. But that's a fault at the broker level, not at the blockchain level. So still being worked on.
So next question, I'm really sorry to delete this kind of highest rank question because it's really kind of more technical, but you will answer it afterwards, and we're focusing on the more business questions, and one of these is couldn't like the ongoing banning of cryptocurrency put an end to the whole story?
I think it's going to make it stronger, actually. I think the countries, what you have to look at is the countries that are trying to, or the shall we say, the governments that are trying to ban cryptocurrencies are also investing really heavily in how to take advantage of it too. So I don't think that the banning of it is going to. I think you'll see fluctuations in value based on some of these bans, but the very same entities that are trying to ban it are also trying to understand how to take advantage of it and use it effectively in their governments also. So I don't think the banning of it is going to be an impediment to the growth, honestly.
So maybe if you ask why the people have been laughing, it's...
Are you Satoshi? Damn it, busted. Yeah. No, I'm actually Keith Richards. No, sorry.
So the next question would be, what blockchain projects you personally think are really like interesting?
Oh, God. Well, so because I work in logistics right now, I think logistics has some really interesting use cases for blockchain. But I'm also fascinated by identity management, sort of that know your customer example. I think that's something where if you solve an identity management problem with blockchain, it opens up a whole world of other problems you can solve. And so that's very interesting to me. Coming from working in the healthcare industry also, I think healthcare has just huge opportunities because of the kind of data that's in it and the kind of transactions that you're affecting in it. So they're all interesting to me, really.
So you're not Satoshi, but somebody wants to know how
many Bitcoins do you
don't
own?
Have to tell.
It was, put it this way, it was a really sad day. Not enough so that it would kill me, but enough so that I'm interested in it. How's that?
So
I'm still working for a living, put it that way. I should tell you everything you need. I have to tell you, though, I have a friend who, he's 30 years younger than me, and he actually just bought a house with the money he spent. He bought Bitcoins with, like, 10 years ago. And the most frustrating thing is I use Coinbase, and you can scroll down and look at your history. And my very first transaction 10 years ago, it said 4 Bitcoins, $8, transaction canceled. It took too long. I was like, oh, this is never going to work. But I have to send them my passport. Forget it. There's someone to get rid. Who am I going to send my passport to? Literally, I should have put that on the screen. It literally says transaction canceled. It's like, poof. So, yeah.
So next question. What do you think, what kind of influence will blockchain have on like these Vorarlberger companies, like the big ones, maybe Bloom or Altland? You think they're like spared out of this movement?
Well, I will say that people are interested in talking to me about it. So, and people are interested in talking to, the students are interested in talking to me about it. I gave a presentation about disruptive technologies to the Chamber of Commerce here in Vorarlberg about 2-3 months ago. A lot of people are really interested in it. Interestingly enough, people who are interested in it a lot right now are lawyers and tax people because their clients are asking them about it. How are we going to tax this stuff? I'm not offering you any tax advice, believe me, but they're very curious about how this happens. I went to talk to my tax guy last week about a completely independent matter, and I just happened to mention that I was doing this blockchain talk, and he brought in like 3 of his coworkers to talk to me about blockchain. I was like, God, it's everywhere. So I think there's a lot of critical mass here in Vorarlberg around it, and the more the merrier. So.
All right, I think we have 1 or 2 more questions.
Oh, can I pick one? Jeez.
So the next one maybe will be this an interesting one.
Yeah, private closed chains. Yeah. So private closed chains versus public ones. It's my personal opinion that private closed chains are going to rule the world because it takes advantage of the design patterns in a way that allows enterprise class tools to be built around them. Like IBM has Hyperledger Fabric, which is built around that very idea. The world of the public chains, you're beholden to what everyone else is doing. You're beholden to a sort of a crowdsourced consensus of where the technology is going. With private chains, you're able to take ownership of a lot more of how you use the technology yourself. And I actually, because I believe in the design pattern more than I do in the companies doing it, I think that private chains and that kind of world is actually going to be 10 years from now much more prevalent. I will say, put a caveat on that, is that I also, when I worked for Gartner, I actually said that OS2 would be on everybody's desktop in 5 years. So that didn't happen.
So maybe last question, and then we close it.
Sure.
So how can you stop kind of criminal activities in the crypto area, like terrorism, stuff like that, financing it?
I think that falls into the same category as the social contract conversation. That is, how can you do ethical things with a technology which doesn't, where your ethics are not enforced by law, are not enforced by taxation. I don't really have an answer, because I think that idea of how we introduce ethics into technology is still being resolved. But one of the things is that these technologies, you can do stuff on them, but right now, in order to be functional, you need to transact somehow. You need to get something in and out of it. Just having money on the chain doesn't do you any good. If I need to buy a house, for example, or I need to buy a book or something like that. And it's at those touch points of where you're interacting with the real world that some of the ethical conversations come up. Like, who do I report this to? Who do I report my transactions to if they're done? And that will feed into some of the security concerns around who's using it, how they're using it, and things like that too. But I don't have a really great answer for that, but it's something that I'm definitely interested in talking about more. So.
Well, thanks a lot. We have more time for questions outside,
okay.
But before we go outside, we have 2 more things we want to tell you. So first, thanks for your talk, Frank.
Thank you.
It was great having you.
Thank you.